Today, I'm going to talk about how Capital One uses Node.js and open source software responsibly. First, a little bit about me. My name is Steve Husak. I'm a distinguished engineer at Capital One. I've been there since 2014. Actually, this is the month of my anniversary, so 8 years there. One of my primary responsibilities is being the intent lead for Node.js and JavaScript at Capital One. And what this entails is I am the enterprise lead for all the governance and rules and policy and everything we do around Node.js and JavaScript. My day job is I'm a solution architect in our commercial banking space. I work on our underwriting and loan servicing platform, which in itself is interesting. But not germane to this discussion. Also, one of my passions is I'm passionate around developer experience and engineering standards. So since this is an international conference, I wanted to bring up Capital One and what it is, if you're not familiar. We are a large US-based bank. We have a little presence in the UK, some presence in Canada, but mainly the US. We're known for our credit cards. However, we do have retail banking, commercial banking, and auto finance. One thing that we've done over the years is we've become a tech-first company, meaning that we really take our tech very seriously. We were one of, and probably the first bank to be all in on the cloud, and we don't have any on-prem data centers anymore. So that was a big thing for us. And our mission in general is just to change banking for good, which means for our customers, we want to make it easy for them to manage their money in a responsible manner. So what I'm going to get into now is a little bit of the security landscape for Node.js and how it's changed dramatically over the years. I think we're all familiar with the amount of things that have been happening in the ecosystem of JavaScript and Node. So a lot of this seems bad, but Capital One has many things in place to kind of protect us from the vulnerabilities out there. First of all, there's several different classes of attacks that we're most concerned with at Capital One. The first being cryptojacking. This is where code is inserted into a package, and it basically to steal computing resources and mine for cryptocurrency. There's an example here of UA parser JS was the popular one that got hit with that. There's typo squatting, and this is utilizing common misspellings to install either malicious code or a completely different package. A good example of this is React Modal versus React Model. There's dependency confusion, which is probably one of the things that an enterprise can be susceptible to. And this is, I'll get more into this one on the next slide. Then you have data harvesting, ransomware, hijacking, and then even authors doing their own attacks, which I consider a denial service. I think some of the most recent ones were Colors and Faker. They just went into an infinite loop, essentially, and the author was making demands. We also have the one that was erasing hard drives if your IP was in a certain location. So one example that corporations and enterprises are most susceptible to is a supply chain attack called a substitution attack. And in this attack, an attacker will actually go and search the public GitHub and look for public repositories that contain package JSONs and look up the dependencies within those package JSONs and see if they exist on the NPM registry. If they don't exist, they have a pretty good idea that that's probably based on some internal code somewhere else. So what they do is they can then publish a modified package, increment the version a couple or more, and then publish that version on the NPM public registry. So what happens then inside your enterprise is your developer will query their local mirror for the latest version through a normal NPM install or what have you. And the mirror will first determine that, hey, you're looking for the next best version. I don't have it, so I'm going to go to the public registry and give you this brand new version. And then the mirror will pull it, cache it, and then all your developers internally will have the latest version, which overrides the legitimate version. And then you have a hacker who has gotten into your network at some point. There's a great article here, which I'll try to click on, that goes more into this. And you can see just from the headline, some of the companies that are, oh, you're not seeing my screen. Duh. Sorry. All right, I'm not going to play with that right this second. In any case, some major companies were hit with this one. And so some of the ways that Capital One deals with this is we really are intentional on being well managed. And we do this in several different ways. The first way is we are very intentional on our usage of Node.js in itself. We also use what we call golden images. I'll get more into that in a second. We use working groups to help drive a culture of responsible use. And when I bring this up, this is not necessarily Node.js related. We also do this for our other languages that we support at Capital One, so Python, Go, Java, C#, you name the language, we have a group around it. A good practice is tracking your package uses through the use of software bill of materials, or SBOMs. And then there's a couple techniques to kind of make this less of a toil on your developers. And by using tooling and pushing left the detection of these vulnerabilities and issues. And then you can adopt best practices around security, training, and usage of your components in your lifecycle. One thing that we found very valuable is having metrics and associated dashboards allow us to see how we are being well managed in general across the entire enterprise. So for us, for being intentional on Node.js version usage, is we have a life cycle here that starts with the upstream. And the upstream is nodejs.org or whatever we are. And when they deliver a new version that's released by the upstream community, we pass that version through our maturity criteria, which I'll get into on the next slide. And we go into an adoption phase if that passes. That means we're allowed for use, and then we're in a support phase where we're continually using the version until it hits end of life. Once it hits end of life, we discontinue the availability of the version and strongly encourage our developers to move to a newer version. They have no choice. So the maturity criteria that I mentioned is, for us, we only consider LTS versions. And we only consider the active or the maintenance. And we always prefer the active over the maintenance. And this is just to get the new features, obviously. But you'll see that we don't really use the current at all at this point. We wait till it's actually officially declared LTS. So in a couple weeks, we will be pushing 18 to our developers for their use. We always accept security releases on or about the day of release. And when we do take those security releases in a LTS line, it always supersedes all previous versions. So if we had already approved a couple minor versions and a security release comes in, those minor versions are automatically not allowed anymore. We lag our minor releases by 2 weeks. And this allows for the discovery of critical issues in those releases, either by the community itself or by our internal testing. And then we move to major releases when an LTS is declared. We rely on the lag that's already built into the Node.js release cycle. So we feel pretty safe going at that time. However, we know that some of the libraries can still lag, and so we make sure we do some testing around that before we actually use it. And then we deprecate on the Node.js schedule, and this is kind of non-negotiable. We always encourage our teams to move to a new version way before the end of life dates, like a couple months. We don't like to get up against that line of the end of life. Um, so I mentioned golden images, and what golden images are for us are golden images are usually they're usually Docker containers, but they can also be Amazon Omnis. These are centrally owned and built by one of our operation teams. They have known vulnerabilities at the time of building. Like I said, they're centrally hosted, and these are the basis for all of our downstream container images. They are continuously updated for OS-specific vulnerabilities. And then when Node.js is released, we update the Node.js image based on the maturity criteria I just went over. These images also have some enterprise scanning software and that kind of stuff in them, so they're configured already for enterprise use and compliance. For Node.js, we do things like set the registry to our internal registry. We set our certificates in there so that developers don't have to worry about setting the certificates, and we make sure they're secure out of the start. One thing we're starting to look into is distro list images, and this is just to decrease the vulnerability surface and the associated maintenance of dealing with all those OS patches as they come out. One thing that I mentioned before was the working group concept. So while this isn't specific to Node.js at Capital One, this is kind of what we do across as a best practice through our open source program office. So the working groups they meet on a regular cadence, and the main group is to govern and recommend the best practices and policies for use of Node.js in this case, within the enterprise. It's usually made up of a group of people who are very vested in Node.js within Capital One, and we do require that all of our major platforms and products that use Node.js or JavaScript have a member on the committee to ensure that the policies are palatable for everybody involved. The Node.js group has some specific responsibilities, and these are probably a little more detailed than some of the other groups for our languages. But the first and foremost thing is approving those Node.js versions as they come in based on the maturity criteria. We also generate the policy for responsible Node.js and JavaScript use, working with our open source program office. We drive any Node.js or JavaScript specific, what we call enterprise tech backlog items relating to policy adherence. So if a major vulnerability came out, we would declare an enterprise tech backlog item, and that would allow us to push work onto other teams to help remediate that. Obviously, we promote the safe and responsible usage. We provide our SMEs for code reviews, for any public-facing open source projects. We promote contributions. We're just getting started here of this part of the working group. And we are working on driving the automation of our language version approvals. Right now, it's a manual process, and we're looking to make that a little more automated in the future. And one thing that we also do is we deal with our community images. And community images are a little more specific than Node.js itself. A good example of this would be a Docker container that contains Cypress for testing. So this group is in charge of making sure the Cypress image is kept up to date and ready for use within the enterprise. And then we own the public registry presence of Capital One. Oh, one thing I did want to mention with the working group, we recently held a mini conference on Node.js at Capital One to allow our teams to kind of work together and find out how other teams around the company are using Node.js, and found a very successful way of fostering that community even within the walls of Capital One. So another thing that we highly recommend is tracking your package usage through the use of software bills of materials, or SBOMs. And for us, this is a required artifact for a release, and it basically allows us to audit our software releases and helps us provide visibility into what is in use. And when we aggregate these results, we can know the frequency of use, common packages that we use, and this can also help us in the detection of unsanctioned use or remediation activities related to vulnerabilities, licensing, or deprecations. So a good example of this is auditing for the use of request, because we know it's deprecated. However, it's still in use in a lot of places, and this is how we can start to report that out and create one of those enterprise tech backlog items to have people move off of it. Moving on to the developers. So our developers, we invest really heavily in them to be up to date on security best practices for coding. We encourage them to be aware of the top 10 OWASP and the common remediations for those. We obviously know and educate not only our developers, but our product and business partners that the security landscape is always changing, thus requiring us to appropriately prioritize work in this space. And we want our developers to keep our dependencies up to date. And so a couple other things we encourage our developers here is for evaluation of packages before use. So first of all are the processes. We just encourage our developers to not just go out there and find a package and start using it. We want them to do a little due diligence first. And so we encourage them to use publicly available resources to look up packages before they're used. A couple examples are up here of some of the ones we point to. And that allows us to evaluate the packages before we actually bring them into a software application. We evaluate the packages based on release cadence, their current GitHub issues, how fast those issues are turning over, that sort of thing, and the general maintainability of what we're trying to bring in. And then we also use industry standard tools to scan our dependencies, and this happens on every PR. One thing we do is we do block our releases when the standards are not met or a certain level of a CVE exceeds our thresholds. So people can't release if the scan tool has determined that you have a CVE of, I forget what it is, like 8.5 or better. So obviously you can't lay this all on your developers. You should have tools in place. And before I even go into the tools, I think the most important thing is for these tools to be very effective, you have to have reliable automated testing in place to actually trust the automation. And the idea here is that you trust your tests, you trust your automation through those tests, and then they can take care of a lot of the toil for your developers. So a couple things here are we don't only rely on scanning for vulnerabilities, we also use static code analysis, linting to capture that low-hanging fruit. We use a lot of tools integrated into GitHub to block our PRs based on our static code scan results, vulnerabilities, and other things. We also use tools that help us auto-remediate and automatically handle our dependency updates. And so the last part here is the production of our NPM packages. So we produce mainly internal packages. There's a couple external, but they're not widely used. But for our internal, we have a couple of best practices here. Obviously, for the dependencies in our packages we produce, we're only going to use those vetted and trusted packages that we did the due diligence on. We lock our versions in our package JSON and use the appropriate lock files, whether using Yarn or NPM. We encourage when you bring in a new dependency that you monitor your network and process activity on the Node.js process itself, just to be sure that anything you brought in new isn't doing anything nefarious. We also don't allow access to external GitHub. This is to protect us from that supply chain attack that I mentioned earlier. It requires a lot of permissions to be able to publish on external GitHub, and we have special tools around how that works. And then for our produced packages, we apply an owned scope to all of our packages. And those scopes are registered on the public registry, and our mirror internally can block or let those through as needed. Recently, the OpenSSF or SSF and NPM got together and came up with the NPM Best Practices Guide, and I'd highly encourage you to read that to get additional, more detailed guidance here. For external publishing, obviously we're going to set up two-factor authentication. I don't even know if it's an option anymore if you can't do that, but highly recommend if it is an option, you have to do it. Also, you should create and own your own organization on the registry. One thing here is if it's already taken, there are ways to reclaim it if you have a legal and copyright claim to it. And obviously, again, using scope packages is probably the best defense here, especially if you own, well, you have to own it at that point. So in summary, keep in mind the vulnerability landscape changes constantly. Being well managed helps reduce your risk. Keeping your developers up to date on security practices and responsible usage will help minimize that risk. You need to have reliable and automated testing to trust the tools that help reduce your developer toil. Having the dashboarding and monitoring really gives you a holistic view of your security stance. And following the recommendations on publishing on both internal and external packages is equally as important. So that's all. Thank you very much, and you can contact me in any one of these ways.